And we're going to do 2 of these problems, and then we're going to show you some other stuff. You notice we got a list of spreadsheets here, and actually I should have done one thing before this. Sorry. Go back to home, and go new document. Actually, first. New document. I'm not going to save. You can save if you got some stuff you want to save. If you have notes you've been taking notes on, make sure you do save, because you'll lose all your notes otherwise. But save it. But I'm not going to save because I don't take notes. And then once I do that, I'm going to go to list of spreadsheets again. And the reason I say new document, because last hour we did the same thing, right? And if you define, and we're going to define our x variable, and then you come to this class and you type in x, which I'm going to have you do in a second, you're going to get a whole set of values already in there because x is already defined. So if you have other people using your calculator, you might get some weird answers as you go, because if somebody else already used it, it's going to cause some trouble with your calculator. Okay, so that's why I always start a new document when I start a problem, or know how I work my problem. Okay. So what I want you to do at number 8, if you look at number 8, you got a whole set of points here, right? The first point in any point is your x. Second point is your y. Okay, so I want to label my first column. I want you just to arrow up here, arrow up to the very top, label your first column x, tab over, label your second column y. Now what I want you to do is arrow back down to the x column, enter all your x's in. Enter all your x's. And then you go back and do the y's too. Yeah. So I'm going to enter my x in 0, 2, 3, 7, 8.
You forgot 7 on that.
Yeah, I can see that. Yep, there's my points. Everybody got that? Now, the first thing I want to do, and I'm doing this a little different order, but that's okay. First thing I want to do is say, is this a good linear model? Is these points good? So I want to graph them. Now, on these calculators, graphing points are hard to do. We can graph gradients all we want. But points are a little bit more difficult. So what I want you to do, you kind of have to follow along, graph the points. I want to hit home. And we went to list and spreadsheets last time, fourth one over, right? I want to go to the 5th one over. Data and statistics. And you'll see some points. These are not our points. They kind of are, but they're kind of not. And now you notice on the very bottom, on top and left, and bottom and left, you'll see it says click to add a variable, right? If I'm thinking about the axis, which axis is this? X, and which one is this? Y. So what I want you to do is just arrow over until you get down there, and it'll ask you to click to enter to add a variable. So what I'm going to do is this arrow there, click and hit the center button, and what shows up is X or Y. Correct? Yeah. Not all along. Which one do I want?
X.
X. Click the X.
I clicked the X and now I can't find the Y.
If you arrow, you mean over here you're talking?
Yeah.
You just arrow over, it'll show up. Mine doesn't show up either. If you just arrow over here and get close enough, it will show up for you. It just takes a little time. And then what do you want on that side?
Y.
The Y variable. So get over there and click the Y. Everybody getting that?
Don't you percent like scroll
They'll fit the screen to it.
Oh.
Actually, in this problem, they'll flip the screen. So now on here, I'm going to get my Y here. Y. And it moves nicely. Points scattered around, right? Is it a good equation? Not too bad, right? Now, the one thing I asked the other day, and some of you said, when you did regression before, best line, best fit, you plotted the points on a graph, and then you took a straight edge and you drew a line between it, right? And you said this looks like the best line, correct? We do a little different here. The book does something like that. I don't do it that way. What I do is this. I go to menu. Okay. And then I go under analyze. And then I go under regression. And under regression, you'll notice there's a lot of them. Which one do you think we want? Mx plus b. We're doing a linear one. You notice there's two linear ones actually. Linear mx plus b and linear a plus bx. A plus bx is statistics. So we're not using that. We're using the mx plus b. So just click that. And you'll notice once I click that, my line's drawn. It's kind of like taking your own straight edge and draw it in. But what's nice about this straight edge is it is the best line. It isn't questionable. It is the best line. So there's no question about it. So I mean, so there, what is my equation that best fits these points? Y equals negative 1.32609x plus 10.9043. There's my equation. Y equals nx plus b. Found my equation. Do you think it fits pretty good? Not too bad, right? If I was looking at the points here, this one's okay. This one's a lot on the other side. This one's in the middle. These two balance off. You think it's a pretty good fit, isn't it? Not too bad. Now, if I drew another one, you don't have to do this. I don't need you to do this. I just want to show you something. If I went on here, analyze, regression, and I'm going to show you a quadratic. There's my quadratic. Does it look any different? No, it doesn't. Now, you have to be careful with this. When I do a quadratic, someone will do this and say, oh, a quadratic looks perfect too. But what do we know about a quadratic equation? It curves. It goes back up. It's going to look good for one side with these points, right? But what's the problem is it curves back up. Are the points going to look good if it curves back up? No. So you kind of have to know what kind of equation you're looking for. Any equation you can type in here usually looks pretty decent. I don't know about a cubic, maybe a cubic, I don't know. Regression, let's just go cubic. No, a cubic's actually getting really good there, right, through the 7 points. That's not too bad equation either. You know, so you look at these points and say, which one is the best? Some are better than others.
Instead of like always redoing your points and going to your document, can you just go back to like control to slide 1 and change your points and
Yes,
then
you
it'll
can.
show the
Yep. Yep. And I don't know if it'll show you a line in this graph, but I do want to talk about a couple of things. It probably should change your points, does it?
It changes the points and it gives you your new line.
Okay, then that works perfect. Now, I want to talk about one thing. A lot of you have been using your calculators. In some of the functions I'm going to show you today when you do this, a lot of you have been using Scratchpad, correct? Now, there's two functions here. There is a Scratchpad right here, and then there's this button right here. My advice is to use this one all the time. Don't use Scratchpad. Okay? And the reason being is, if you use this one, when we do some of the functions today, like factor and expand and all these functions, it will work. If you use Scratchpad, none of those functions work in Scratchpad. Scratchpad is like a notebook piece of paper. It's like just writing on your finger. So it's just like I said, it's a Scratchpad. This is a function tool. Okay? So if I was doing any of this, I would do it in this one down here. Okay? Now, I'm going to show you one other way to do this. And the reason I want to show you is I want you to see one value. So I want you to go back. I'm going to go back to my screen. Most of you are on this screen right here, but with the graph, right? I want you to use your control left arrow to get back. I'm going to go back to get back to this screen. You know, and I want to show you a couple things. You know, kind of one of the ones that I kind of talked about too. But what I want you to do is I want you to do the same thing here. But we're going to come up with the same equation, but a different way. I want you to go to menu. I want you to go down to statistics and stat calculations. Okay? Now on here, you'll notice the same ones here, right? A lot of regressions. We're going to do the same one again, the linear regression, right?
MX plus B.
MX plus B, we're going to do that one. And so it asks us a few more questions, first of all. My X list. What did we call that X list? Nothing real fancy. X. We call the X list X. Nothing real fancy. My Y list?
Y.
Y. Now the next two things I want to talk about, we're not going to change it. You have to remember what this is. F1. This is an important part. F1. Remember what that is. It'll change. It could say F2. It could say F3. It could say F4. it will change. But remember what it is when you're using an equation. Okay? And the other thing I want you to remember, frequency stays at 1. And the other thing I want you to remember is this down here. Not remember, but make sure of. You'll notice that last thing, it says first result column. Mine says C brackets. I think all of yours should say C brackets, right? Was that?
Mine says D.
Yours D should be okay. Yours says B.
Mine
You
says-
might have changed yours. Change yours. Just type in C there.
Mine says D.
D should be okay. Go on. What this first result column means is this. A column, we put our X values, right? B column, we put our
Y.
Y. Which one's open next? C. Now, if you had D, D's probably open too, right? So your answers, this just tells you where they're putting your answers. Now, you had B. If you had B as your Y column and you're putting your answers in B, what's going to happen is your calculator is going to say error. It's going to write over all your column. Okay? That's why when you want your result, make sure it's in a column that you don't have anything in. Otherwise, you're going to have to start all over again. Okay? And then hit enter. Or okay.
Save regression equation to F1.
F1, yes.
Give her 14. And then give her 10 on this one. The one that's good. Good.
Mine says argument must be a list.
If you were- You didn't do that. Come on. Just have a- Oh. And if you do variable reference on that, you're allowed. Make sure you do it.
If you get a screen that pops up that says word reference or something like that, make sure it's always variable reference. Notice that we have the same equation here. Y is equal to negative 1.32, right? And B is 10.90, correct? Same equation that we had on the other screen, right? But the thing I want to point out is this value. Hang on one second.
Two things. I need the iPad card out of the studio. Bring it in, bring it in here. And then the back door to school. Okay, my muscle's working out today. In my athletic card, there's like 3 boxes of books. It says who nothing on it. I think my name's on them. Bring them and put them in the back table. Okay?
At the back.
Very back door as you go out.
You notice that R value is a negative 0.998, correct? Okay, here's that. That tells me how close my line is to actually fit a linear regression. The closer that value is to 1 or a negative 1, the better the fit is. Okay? Negative because it's a decreasing equation. Okay? How close am I to a negative 1? Very close, right? Is it a good equation? Yeah. Now, when I asked this question this morning, I thought it was interesting. I said, what would be bad? What value would you think there would be bad? Would 0.5 be bad? Nah, that's pretty far away, right? Would
It's supposed to be a
negative 1 or 1, either one. You know, all your values are going to be, your value is going to be between negative 1 and 1 always, okay? That value R. Now, I always say this, 0.999 is great. 0.990 is great. 0.95, it's getting bad. 0.9 and probably between 0.9 and negative 0.9 might not be the best model. It's not far away from 1. But in statistical terms, that's a long ways away from 1. So the closer you get, you know, 0.9 won't be bad, but it'll be okay. Okay? But if you got 0.5, not even close. Not a good one, okay? So something to think about as you go through there. Any questions on that so far? Now, what Hannah mentioned earlier is this. Let's say we do problem number 12. Look at 12 in your book. And number 12 says the measurement of shoe sizes in the U.S. compared to Europe, right? let's let x, I got my x in my list already, x be my US Massachusetts. Okay? X is my US. Y is my European, right? Now let's go back in my x list, go up here, x is US, and let's put our values in. That table. Now notice as I'm putting my values in, I didn't start a new document here, but notice as I'm putting my values in, 1, 3, 5, 7, 9, might give me a message, 11. It's going to give me a mismatch message. That's no big deal because I have an extra value. Now I'm going to go up to my Y column, and I have 31, 34, 36, 39, oops, 36, 30. Okay, let's start over. 31, 34, if I can type today. 34. That mismatch, I should have put that one in right away. 36, 39, 41, 44. What did you notice as I was putting those values in? Everything changed. Did I have to do all those steps over again? So all my values over here changed automatically. Did you get to work? What? Did you get to work? Work?
Yeah.
Everybody get to work? Or you got a question? Yeah, we don't have to work. We're going to do this for the next 6 months. So make sure, if you don't see this, make sure you know how to do this. Because we're going to do a lot of this. Does everybody get the equation that looks like this? 1.27, 143, 29.8714.
Yeah.
Yeah.
So now notice my R value here. 0.998. Is that a good model still? Yeah, it's a good model. Notice a couple things in here. 1.27, 143, 29. This is what Hannah said a second ago too. Notice my graph, I believe. I can't see my graph now. My points are too big now. I would have to zoom, redo this graph as it goes. So I would have to go down here and click my X, and click my Y, and it does not look too bad of points there, correct? So as you go, I'm just going to go back here. What would my equation be? Y, I think it actually is right here. Oh, there's 2 boxes back here.
Yeah. Do you want me to take them out?
Yeah, why don't you start stacking them on the back table back there? This what's in the boxes. I have to look through all that stuff.
So we got Y equals 1.27143x plus B, which is 29.8714. Okay, everybody see where I got that for? M is my slope, right? B is my y-intercept, correct? Good model. Now let's think about it. What was X again on this problem? X stood for my US size and Y stood for my European size, if I spelled European right. Correct? Now Y is the same thing, and if you remember back from the last section, Y is the same thing as f of x, correct? Everybody agree? Okay, so now, let's answer question B on number 12. Question B. I want you to look at it for a second. So now, here's the deal. The question says on part B, find the European equivalent when US size is 8. Plug in 8 for X, right? X is my US size, right? So I would take this equation and plug in 8, right? So if I was solving this down, I would say 8 times this, right? Plus this gives me my f of x, right? Okay. Can you do that for me real quick? Did you get an answer? 40.0428, right? Now this is where it comes in handy. Sometimes it might be handy here. You know, when we did this equation, we wrote down, I told you when we did that regression, make sure you remember what what that f of 1 is or f of 2 is, right? This one was f of 1, I believe, on your calculators. F1, and what number are we plugging in here? 8? F1, 8, 40.0429. It remembers the equation. So when you come up with a regression, it remembers the equation. It puts it all over the place in the calculator. And so it remembers how to do that. So if I ever have to plug that in, it does it. So if I wanted to know, okay, so let's say I have a shoe size of, I'll use my son's shoe size, 13. If you want to do size 13, what is it, European size? Well, I'm going to plug 13 in for X. Well, I'm just going to go on my calculator, F1 of 13, hit enter, European shoe size would be 46.4, right? It take you long to plug that values in? Solve it now. Now let's do part C. It says, how about if I want to, if I knew the European shoe size? Let's say I knew the European shoe size was 50. How would I find the US shoe size? What'd you do? F1 equals 50. Not F, oh yeah, on the calculator, yeah. Or I plug in 50 for Y, right? If my European size was 50, I plug in 50 for Y, and then I solve for X. So I would have to subtract this value off, right? And then divide by this value, correct? So let's try it by hand. Plug in 50 for Y. Get an answer for me. Yeah, that's all I have. That's all I have. Check it. Thank you. Okay, got an answer? European size of 50, do you think what US size? 15.8315 or approximately 16, right? Okay. Now I could do this too on the calculator. Now I don't know if I showed you this stuff before. I could go on a menu, algebra, solve. So I think it was Dan or somebody said that F1 equals 50, right? So I'm just going to type in F1 of X equals 50, correct? But now here's the only thing, whenever you use the solve button on your calculator, what you have to do is this. You have to tell the calculator what it's solving for. What are we trying to solve for? Not comma y, but comma, we're solving for x, so comma x. We had to tell the calculator what we're solving for. We plugged in 50 for y, didn't we?
Oh, yeah.
We plugged in 50 for y, so comma x in, it gives me the answer of 15.8315. What's nice about this is when you get an equation in the calculator, you don't have to keep typing that equation over. If it's f1 of x, it's f1 of x. If you want to put another equation in, you take an f2 of x, or f3 of x. And yeah, with a lot of parentheses, it cause trouble too. The other thing I want you to think about when you solve this down is that f1 of x equals 50. That's the 20 answer. Now, I don't want to always type this over, and I'm surprised people. Okay. If I wanted to do this again, let's say I wanted to know what US shoe size was for 80. Correct? It'd be a big shoe. But for 80, right? I'm just going to use my arrow up, highlight this, arrow over, delete, change to 80, and hit enter to get my answer. Okay. One thing nice is this. If you ever use your up arrow and it's highlighted, once it's highlighted, that's like a copy on a computer. That's copy. If you hit enter, that's your paste. Okay? If I hit highlight it, it's copy, enter is paste. Questions on that? It's kind of a nice little feature there as you go through. And now it doesn't have to be F1. Remember last chapter we were doing this? We were solving down this equation, and I asked you to solve down, let's say x squared plus 5x plus 6 equals 0. Remember when we did that? And said, solve it down. Find me the answers, right? I can just type that in. Algebra, solve x squared plus 5x plus 6 equals 0, comma, x. There's my two answers. It's like teeing it up in all in one shot. It does all the teeing up, it did the quadratic formula, whatever. It did it all in one shot. Now there's one case like this, so I'm just going to highlight this. Let's say I go up here. X squared plus 6 equals 0. False. What does that mean?
It's not true.
Not true. Is it? No solution. It means it's imaginary answers. Remember I? Imaginary answers. Now if I just change one thing here, and I put a C in front of here, just the letter C, which means complex solve, it gives you the imaginary answers too. It's telling me all the imaginary. So you can tell me all the answers actually. So, which is what? Oh, I don't answer. It tells you all the answers. Also, you can use this, and this is a nice feature that some of you have already been using. If I want to factor an equation down, let's say I want to factor. Remember I factored in the last book. Oh, that didn't work. That's a long. Good example though. I factored down x squared minus 4, right? You notice what I got for answer. Not the answer I want. Why? Because you know I did that list, and I labeled that list X, right? What it do is it went in here and said, I'm plugging in that X value and every X value in that list here because X was defined, wasn't it? X was that list. So what I might have to do here, I'm just going to start a new document and do that same problem again. I'm just going to go back here now. I cleared that list out. And I'm going to do x squared minus 4. And x minus 2x plus 2. Factors it out. So these calculators will do a whole bunch of stuff for you. It won't. It does everything for you. It's good and bad for that. So when we get into the chapters now, quadratic equations, some of your stuff today, it's going to be hard to do without a calculator. As we move along here, what's happening is this. As we get more and more chapters, can I test you and say, okay, here's a test in class on chapter 5, this book, chapter 5. I'm going to have
Factor these problems down. Well, you can just go on your calculator and type it in, right? So what I do there is this. You will have an option to do a test online. Online test will be calculator optional. The class test in class is no calculator. So I usually do 2 tests, 1 calculator, 1 non-calculator. So make sure you understand that you have to do it both ways. You still have to show some, you know.
So then, like, say that's the equation we're working with.
Yep.
Would you like to solve that by hand?
We're gonna have to solve. No, I wouldn't say solve. I'll show you some different ways to solve by hand. Sometimes, like in this
But I
one,
mean, like, if you're gonna plug in 8 for that, you'd have to multiply 8 by the 1.27.
I wouldn't give you that part of questions.
Okay.
If I was doing a one where no calculator, it might be y equals 2x plus 5.
Oh.
Something along that line. And sometimes I just leave the answer and just say, you might explain, not do it, but just explain what you do. And so if I was doing this, I'd say if I plug in 8 into this equation, I would take 8 times 1.27431 and add on this value to get my answer. You wouldn't have to find it, you have to explain what you're doing. So that's kind of where the numbers get bad.
I had a question on the homework. 5 through 7 and 22 through 26. Can you just set up a ratio and cross multiply?
You probably could set the ratio with those two to get your slope kind of thing, you say?
Yeah, because it'll give you like 2 leaves along 3 inches. How many is along 6? So 2 over 3x over 6 cross multiplying divide.
You could get your answer that way too, yes. But if it says to find your linear regression, or find your linear equation, you have to find the equation. It has to be the same ratio as you go, so.
So when it just says make a prediction.
Then you can just do the cross multiplication too, so. This is the last section that we're covering in this chapter. Just make sure you know all this stuff. This will be the first test of the quarter. So we have a lot of, we're gonna move through this, and then probably in another week or so after this test, we'll have another test. We'll get to chapter 2 pretty quickly here. So make sure you are ready for it. Your assignment to know on this stuff is 1 through 30 on that same page you did yesterday. You want to make sure you do all problems. You had the ones yesterday, and so today you're doing the rest of them.
When it says decide whether and when a model is feasible, does it mean like if it's closer to the
Negative 1 and 1, yep. So make sure you work for the last 5 minutes here, please.